Okay. But secondly, let me come back to that. Secondly, what about the bad z errors? There aren't any. How do I know there aren't any? Well, I mean, not necessarily true, but in this case it is true. Because, so what are we worried about? We have a distance 3 code, so I'm worried about a single z fault causing a weight 2 or higher z error.
Yeah.
Okay. But, we showed this as a perfect CSS code, which means that any set of z errors is equivalent to either a weight 1 z error or a weight 0 z error. So it's impossible to have a weight 2 z error. I mean that's because I'm preparing logical 0.
Yeah.
So like, for example, a I, for example, z1, z2 is equivalent to z3. And in fact, 82 z errors is equivalent to a weight 1 z error. And so it's impossible to have a bad. So I don't need to worry about the z errors. I only need to worry about the x errors.
So if we were preparing logical cat plus, they would just switch.
Yeah. So that's nice. So okay. So again, we're back to this question about what to do about the x errors, and I don't know. Like there could be some special trick that works for this circuit. I mean, maybe, I don't know. It's something you just have to sort of check and figure out for yourself. Or there are some things you can do that generally works. So for example here, if I call this circuit E, or I don't know what to call it, C. So C is a circuit that has no inputs and the output is 7 qubits, hopefully in logical 0. Like that. So one thing you do is you could prepare 2 of these. You do transversal C0s from the first one to the second one. And this should be 7 C0 gates. And then you measure this one in the 0-1 basis, the Z basis, transversely. And so what's going on here? Let's see. So it's more complicated, right? So if you have a single fault, it could cause a weight 2 error, like x1, x7. That will be copied down to here. Oh, I see, sorry. First of all, if there's no faults, everything works. Because a transversal C0 gate is a logical C0 gate, but it's a logical C0 gate from logical 0 into logical 0, so it doesn't do anything. And then when you measure this, what you'll get is you'll just get, you're measuring every qubit in the Z basis, so you'll be able to measure these 3 stabilizers and also this one. Okay. If there is one fault, it could cause a weight 2 error, but then you'll detect it down here.
One fault on the first circuit.
Yeah, if there's any error at all, if there's one fault here and it causes any error at all, weight 1, weight 2, or whatever, it's going to be copied down here, and then as long as there's not another fault, you'll detect it.
Yeah, but it seems like if you're introducing an entire replica circuit, that you should also be worried about a single error in that circuit.
Yeah, a single error in this circuit could cause a weight 2 error, or weight 1 error, and you'll detect it and you'll throw away everything.
Oh.
So it's not efficient.
That works.
But it works if you post select on all these syndrome outcomes being.
And it'd be pretty rare for the 2 errors to like. Okay, I see.
Yeah. So this technique does work. I mean, this would work for any distance 3, any perfect distance 3 CSS code, not just this one. If you want to do higher order fault tolerance against more kinds of errors, you can do something similar where you do this sort of recursively. So you prepare 2 copies, you do transversal C0s from one to the other, you measure this one and you post-select them. You post-select this one. And then you measure 2 copies again. You measure the second copy, you post-select. And then you do this sort of recursively.
Oh my gosh.
You measure the second copy, you post-select, and maybe there's more and more levels. And I think what you'll see is like what goes on here. So if there's 2 faults, for example, you could have one fault here and one fault here. It causes a weight 2 error here and a weight 2 error here, which is bad. But they're exactly the same weight 2 errors, so they cancel out, so you don't see it. So now I have 2 faults. Oh, sorry, that didn't work. All right. So you have one fault here, it causes a weight 10 error. Like it's big code.
Okay.
So I have weight 10 error here, and the same fault here causes a weight 10 error here. They cancel out so you don't see it. So now I have two faults causes a weight 10 error that's undetected. But fortunately you'll detect it now.
Right.
Unless there's a third fault.
Yeah, but that's.
Yeah, so
So if you want to protect against false positives, you can continue to recurse.
Yeah, it's something like that. I don't know exactly what the overhead works out to be. So this works, I don't know.
It seems like so far from being practically.
Yeah.
useful.
Yeah, so really, I think what you want to do in practice is you design something that's tuned to the particular code and not just do something stupid like this. Yeah, and in practice, like, I don't know, you can almost always optimize any code to make these kinds of things smaller or simpler.
Yeah.
I'm sure you can do it in this example too, I just don't know off the top of my head how to do it. There's gotta be a fairly simple way of doing it.